Hello students, we are studying the chapter S block elements. Okay, when I say S block elements, what do we understand? It means the electrons in the valence shell has entered the S subshell, isn't it? Like if we take the example of sodium, okay, it has got 11 electrons, okay. Now do the configuration 2, 8 and 1 we are saying, okay. Now according to above principle, 1s2, 2s2, 2p6, 3s1. Now you see here, in this the electrons has entered the S subshell, okay. And here we are seeing the valence electrons which are present are in the S subshell, and so whatever elements are there in S block elements, they will have their valence electron in the S subshell, okay. And we all know that the S subshell consists of 2 electrons maximum. So if it is 1, they belong to alkali metals, and if in the last subshell, okay, if the S block has got 2 electrons, the valence electrons 2, they are alkaline earth metals, okay. So when we talk about S block elements, okay beta, so group 1 and group 2 consists of S block elements. It means their last valence electrons are present in the S subshell, okay. When we talk about group 1, the elements present in group 1 are lithium, sodium, potassium, rubidium, cesium and francium, okay, where this francium is what? A radioactive element, okay. Now coming to group 2 elements, okay, it consists of 2 electrons in the subshell, 2 valence electrons, okay, in the S subshell, okay. So here the elements are, which are present in group 2 are beryllium, magnesium, calcium, strontium, barium and radium, where radium is what? A radioactive element, okay. Now when we are studying this group 1 and group 2, we find that this lithium and beryllium, it shows entirely different property from the other elements present in the group. Like if we are talking about lithium, it is showing entirely different properties from sodium, potassium, rubidium, cesium and francium. And when we see about beryllium, it shows different properties from magnesium, calcium, strontium, barium and radium. Okay, actually what is the reason behind this anomalous behavior of the first elements present in this group 1 and group 2? Okay, actually the reason is that the atomic size is too small, okay, when we are talking about lithium. Very small atomic size consisting of 3 electrons, isn't it only? And naturally if we are talking about lithium, now we will be seeing that if it is consisting of only 3, atomic number is 3, so it becomes 1s2 and 2s1. Very small, isn't it? Very small in size, okay. And as from comparatively from the other elements present in the group, this makes a different behavior for lithium, okay. Now here, because of this small size only, we can say that yes, the electron negativity power is more. It means to attract the shared pair of electrons, the power is more, okay. Its ionization enthalpy, we are seeing that yes, what? The electrons are present in the second subshell only, this S subshell 1 only in the second shell, isn't it? So effective nuclear charge is more. Naturally, to remove this electron present in the last valence electrons present in this S subshell, it becomes very difficult due to the more effective nuclear charge, okay. They don't have any vacant d orbital. It is only till 2 shell number, not third. So here d orbital is absent, no d orbital present, vacant d orbital present. Yes, vacant p orbital can be present, but not vacant d orbital. Okay, these, they have got high polarizing power, and due to this high polarizing power, what happens? They form covalent bond rather than ionic bond. All these elements which we are seeing, they are forming what? The ionic bonds. But yes, due to the anomalous behavior, anomalous characters, okay, this lithium and beryllium also, they form what? Covalent character or covalent bonds. Okay, now one thing we see here, the diagonal relationship. Okay, so diagonal relationship, here we are seeing that yes, lithium shows diagonal relationship with magnesium. Beryllium will show with aluminum, isn't it? So these have the property of showing what? Diagonal relationship. Okay, so why? What is this actually? The properties becomes similar. If we talk about lithium and magnesium, they have more similar properties. Why they have more similar properties? Because their ionic size is similar. Okay, we are saying that yes, what happens, the atomic radius or the ionic radius, what happens as we move from left to right in the periodic table, it goes on becoming small, isn't it? Why it goes on becoming small? Because the electrons are added in the same subshell. Okay, and as the result, what happens? The protons present in the nucleus of the atom, this is, atomic number is increasing, protons are increasing, as the result, effectively just pulling the electron towards itself, the effective nuclear charge increases, and as the result, we are seeing that yes, the atomic radius or the ionic radius goes on decreasing from the left to right. Okay, and that is the reason here lithium and beryllium are showing what? Similar properties. Okay, we are seeing that yes, whatever character we are taking, electropositive character, electronegative character, whatever we are taking, okay, we are seeing what? From left to right. If we are taking electropositive character, it is going on decreasing. If we are taking electronegative character, it is going on increasing. And as a result, this results in the similarity of the electropositive and electronegative character, even the polarizing characters. And this is why what happens, this shows diagonal relationship, like lithium shows diagonal relationship with magnesium and beryllium shows diagonal relationship with aluminum. Okay, now coming to the group 1 elements, okay, we'll be studying the physical properties first, okay. So talking about the atomic radius and the ionic radius, okay, we are seeing that what happens, this atomic radius and the ionic radius goes on increasing, okay, from up to down in the group 1, okay. Why this happens? Because here what happens, the shell number is increasing, okay. So as the shell number is increasing, the effective nuclear charge is decreasing. It can't hold the electrons more effectively, and naturally they will be showing what? Larger size when we go from up to down. Okay. Now coming up to the ionization enthalpy. What is this ionization enthalpy? It is the energy required to remove the electrons from the outermost shell. Okay. And here what happens, the ionization enthalpy, it goes on decreasing. Why? It goes on decreasing. Actually the effective nuclear charge is going on decreasing, and if the effective nuclear charge is going on decreasing, to hold the electrons it becomes difficult, and so to remove the electrons from cesium will be more easy than rubidium, isn't it? Due to the increase in the shell number. Now, coming to hydration enthalpies, okay, this hydration enthalpy, we are saying what? That here this hydration enthalpy decreases with the increase in atomic size or the ionic size. It goes on, we are seeing what? It goes on decreasing as we move from lithium to the down of the group 1. Okay, so naturally we are seeing what? This lithium ion has got the hydration enthalpy the most and cesium the least. Okay, lithium can form very easily LiCl, like it can form LiCl dot 2H2. Okay, very easily combining with water. Okay, now coming to the oxidation state or the oxidation number. Okay, here we are seeing easily it can give one electron. Okay, except lithium. Okay, they can give easily the electrons. So naturally the oxidation state becomes what? +1. Okay, now coming to the metallic character. Okay, when we are talking about the metallic character, okay, we are seeing what? The less the number of the valence electron, okay, weaker will be the metallic bond. Okay, so here we are seeing what? This group 1 element, they have got only one electron in the valence shell, isn't it? So naturally what will happen? They will be having weak metallic bonds. And so we are seeing that they exist here, sodium, potassium and all exist as soft metals. Okay? Now, coming to the melting and boiling point, if we are saying that yes, they have got weaker metallic bond, okay, so naturally what happens here then? Melting point and boiling point decreases, isn't it? And here we are seeing it decreases with the increase in the atomic number. It means what? This melting point and boiling point, as we go down the group, what happens? It decreases. Why it decreases? Here atomic number is increasing. Okay. Now, what type of bond they will form then? If they are having only one in the electron in the valence shell, naturally it will try to give that electron and become stable. So they will be forming which bond? Ionic bond or electrovalent bond. Okay. Here again I will say except lithium. Okay. And lithium is showing the anomalous behavior because of what I had explained you earlier. Okay. Now, coming to the flame color. When you take this salts of this group 1, okay, in the platinum flame test if you are doing, okay, you will see a characteristic color. Okay, so why does this color occur actually? Here what happens, when we are providing heat to it, the electrons are excited to the higher level. And yes, it wants to come to the ground state, and when it comes to the ground state, what happens? It radiates out energy, okay, having a specific color in the visible region. Like lithium, you will be seeing it shows crimson color. Okay, sodium you will be seeing it shows yellow color, potassium violet color, rubidium red violet color, cesium blue color. Okay, now coming to the photoelectric effect. Yes, they are having only one valence electron. They can be used as the metal sheet in case of the photoelectric effect to eject out the electrons easily, isn't it? So here they are used in photoelectric effect. Okay, now here and most appropriate metal will be what? Cesium, because its ionization enthalpy is very low, isn't it? Now coming to the chemical properties of this S block elements. Okay, so first how does they react with air? Okay, like lithium reacts with oxygen to form what? Lithium monoxide. Sodium reacts with oxygen to form sodium peroxide, and potassium reacts with oxygen to form potassium superoxide. Okay, here we are seeing basically that yes, lithium is forming monoxide, sodium is forming peroxide, potassium is forming superoxide. Here lithium, sodium and potassium can also form other oxides also, like this sodium Na2O2, Na2O can also be formed and NaO2 can also be formed, but yes, the conditions should be provided. Okay, but basically when they are reacting with air, okay, lithium forms what? Lithium monoxide, sodium forms sodium peroxide and potassium forms potassium superoxide. Okay, and if conditions are provided, they can form these oxides, all the alkali these metals. Okay, now how do they react with water? Okay, here we are seeing that yes, a general reaction I have written, okay, 2M plus 2H2O gives 2MOH plus H2. Come on, take a specific reaction for this, because here M is representing what? A alkali metal, okay. So here, in this we are saying we are taking what? Na plus H2O. Okay, it is giving what? NaOH plus H2 gas is evolved. Okay, so balance the equation. Okay, balanced. Now here you can see that these alkali metals are acting as reducing in nature also. How? Because here they are converting into positive ions forming NaOH and H2 is given out. Okay, so here they are acting as reducing nature also, or reducing agent also. They have got reducing nature. Okay, now coming to the next, when it is reacting with hydrogen, okay, take a specific example. Okay, Na plus H2 gives NaH. Come on, balance it. Okay, so here we are seeing that yes, this alkali metals forms the hydrides, okay, when they react with hydrogen. Okay, now coming to when it reacts with halogens. So when we are talking of halogens, it comes fluorine, chlorine, bromine, iodine, isn't it? But fluorine, excluding it because the reaction will be too violent. Okay, so here taking this Na plus Cl2, it forms NaCl. Balance it, 2, 2. So when these alkali metals react with the halogens, okay, they forms the salts. Okay, like one example, specific example we have seen NaCl. Okay, now what happens when these alkali metals reacts with liquid ammonia? Actually, when this alkali metal, suppose if we are taking sodium only, okay, Na plus X plus Y, which is the composition of NH3, okay, gives NH3 X. So here we are saying that we are getting this ions, ammoniated ions. This gives a deep blue, or you can say blue color solution, okay, with what? This liquid ammonia. It turns blue in color due to the presence of ammoniated ions, okay. And yes, we are seeing what? They are having charges, so they are conducting in nature, okay, and they are paramagnetic in nature. Then next, if we are leaving this, okay, for considerable time, we are seeing what? That yes, it forms amide giving hydrogen gas. Okay, so here we are seeing what? That yes, it gives out the amide and forms what? Forms amide and gives out hydrogen gas. Okay, and if the solution is left for some time, naturally what happens? It gives hydrogen gas and amide is formed, and this is we are seeing that here it is consisting of ammonical solution only. This Am denotes the ammonical solution. Okay, and yes, if we are taking concentrated solution, okay, of liquid ammonia, we will be getting bronze color instead of blue color, and it will be dimagnetic in nature. Now talking about the uses of these alkali metals, like lithium, it forms alloy with this aluminum, okay, and can be used in aircrafts. Okay, here sodium can be used in vapor lamps, can be used in making synthetic rubbers, dyes. Okay, and in photoelectric cells, cesium can be used, and so there are a number of uses of this alkali metals. Okay. Students, we have studied about the oxides of the alkali metals, that yes, lithium forms lithium monoxide, sodium forms peroxide and potassium forms superoxide when they react with air or oxygen. But yes, sodium can also form superoxide as well as monooxide, potassium also and lithium also. But conditions should be provided to them. Okay. So now we are studying about preparation of hydroxides of group 1 metals. Like sodium reacts with water very easily to form sodium hydroxide and hydrogen gas is liberated out. Okay. Now this sodium monoxide, it also reacts with water to form sodium hydroxide. Okay. Sodium peroxide also reacts with water to form what? Sodium hydroxide, and peroxide is released out. Hydrogen peroxide is released out. Likewise, potassium superoxide reacts with water to forms water, potassium hydroxide, and yes, hydrogen peroxide as well as oxygen is given out. Let us study about the properties of the hydroxides of alkali metals. Okay, they are actually white in color and they are crystalline solids. We will be finding this in the lab in the pellet form, okay, as they are crystalline in nature. Okay, when we are seeing about the basic strength, this basic strength increases down the group. Okay, it goes on increasing down the group. Why does it goes on increasing down the group? Because here we are seeing that as we go from up to down in the group, what happens? The ionization enthalpy decreases. So here what will happen? Naturally, this, if it is this M stands for the alkali metal. Okay, if it is NaOH, it will form what? Na plus and OH minus ions. Okay, so here we are seeing that yes, basic strength increases as we go down the group. So comparatively, if you are seeing, if you are talking about sodium, this hydroxide and potassium hydroxide, whose basic strength will be more? Basic strength of potassium will be more, potassium hydroxide. Okay, and it will be forming easily, the OH minus ions will be released out. Okay, when we are talking about the solubility in water, these hydroxides are totally soluble in water, no problem in dissolving in water. Okay, now if we are talking about stability, okay, so except lithium hydroxide, all the hydroxides are thermally stable in nature. Okay, now here we are seeing that yes, this hydroxides of alkali metals, they normally form salts when they react with acid. For example, we can take the simple example of this NaOH, okay, sodium hydroxide. Okay, when it reacts with acid like HCl, okay, it forms what? NaCl, isn't it? Plus what it forms? H2O. So here we are seeing that yes, when they react with any acid, they form salts. Okay. Now let us see the differences between lithium and the other alkali metals. I said that yes, lithium is having anomalous behavior from because it is having different characteristics than the other elements present in group 1. Okay, so lithium, they are hard in nature. I said to you that these alkali metals are soft because of weak metallic bonds, but here lithium is hard in nature. Okay, why? Effective nuclear charge. Okay, when it is hard in nature, naturally its melting and boiling point will be high or more. Okay, and here we are seeing that yes, hard in nature, more melting and boiling point, these all are saying what? That yes, it is not so reactive in nature. So lithium is least reactive than the other alkali metals, and yes, it is best reducing agent. Okay, now lithium forms lithium monoxide basically, isn't it? Now lithium hydrogen carbonate, okay, or lithium bicarbonate, it exists in the aqueous solution or in aqueous form, but other bicarbonates, it exists in the solid form. Okay, now what are the similarities between lithium and magnesium? We know that yes, lithium shows diagonal relationship with magnesium. Okay, so yes, both are hard but they are light. Okay, both react slowly with cold water, not vigorously. Okay, like the other elements present in the group. Now lithium oxide and magnesium oxide both are soluble. Okay, both are soluble but not to a very greater extent, only to a lesser extent it is soluble. Okay, and their hydroxides, lithium hydroxide and magnesium hydroxide, if it is heated to red hot, okay, what happens? It decomposes, okay, and naturally it forms their corresponding oxides and water is released. Okay, now they both form nitrides. Lithium also forms nitride, magnesium also forms nitrides having formula Ni3n and Mg3n2. Okay, now both have the property of forming the monooxide, lithium also and magnesium also. Okay, when we talk about this, okay, basically we see that yes, in group 1 and group 2, what happens? Ionic bonds are formed, because to lose 1 and 2 electrons it is easy, isn't it? And naturally, if they are polar in nature, okay, so what happens? It will dissolve in water, and if non-polar, in organic solvents. But here we are seeing that both lithium and magnesium, they are soluble in ethanol. Okay, now regarding base, they form bases, but those bases are weak in nature. They are not strong bases. When I say about sodium hydroxide, it is a strong base, but when I say about lithium hydroxide, magnesium hydroxide, they are not so strong bases, they are weak bases. Okay, so this is all for today, beta. Good day, take care.